In this video, I'm going to go through some quick steps on installing the Kubernetes AI Toolchain Operator version 0.8 on Azure Kubernetes Service, and then also deploy a Phi-4 mini language model right onto the AKS cluster. So what is the Kubernetes AI Toolchain Operator? So basically it is a workspace controller. We can call it KAITO. It helps with the deployment of language models. So you can always go to look for the documentation, go through its various steps. There's various branches, but I've done it in a way where you're deploying into a GPU node pool. I've created a script in my GitHub repo, which I've consolidated the steps, streamlined, made it a little bit different to my liking. That's very demo friendly, cost effective. I will show the steps, how it appears in the Azure portal. Well, first of all, the script once set up AKS KAITO allow me to set up these environment variables. I'm already logged in. And so let me go ahead and create this AKS cluster through Azure CLI. There's also Terraform modules through Azure AVM modules. To make it cost effective, I just one node count and standard DTAS v4. Okay, one thing that we need is to enable the workload identity and managed identity, and that is needed for the GPU provisioner. Wait for that for a few minutes. As that cluster is being created, just to jump ahead, there is this YAML file that has the KAITO workspace kind, and this is really a definition and configuration to say, hey, I want to deploy a Phi-4 mini model onto a GPU node pool with this VM SKU that has NVIDIA GPUs. It's quite expensive. You need to ensure that you have a quota limit supporting, I don't know, I think like 16 cores, something around there. And so once it's deployed, it deploys a Kubernetes deployment, and then I will test a curl command to pass it a prompt and then see a response. So now the Kubernetes cluster has been created. Let's take a look at what it looks like vanilla in the Kubernetes portal. Workloads. Just note that these are your basic. There's no other namespaces and services. Get the AKS credentials. Okay, and then here we have the node pool, the system node pool. Okay, and then now the main major step is to install the Kubernetes Workspace controller. So this is the component that orchestrates the deployment of GPU node pools and the language model, basically, in a nutshell. So here's a Helm chart. Okay, now that's been deployed. Just some verification, doing a Helm list. Helm chart is deployed into a namespace called KAITO Workspace. So let's see the condition of the pods. Okay, great, they're all running. Get the description, that deployment, and then let's see how that looks like in the Azure portal. So we have KAITO Workspace, so it deploys these two. So no language model is deployed yet. This is just the basis that helps orchestrate all that stuff. Now we need to create a managed identity. So let me just quickly go through. So the Kubernetes cluster will use this managed identity and added a role assignment to have contributor access to this specific cluster. Run that again. Okay, we see that there is a role assignment there. Okay, cool. So in the Azure resource group, my AKS deployed, the managed identity that was just created is right here. If I go into that, I can confirm the Azure role assignment contributor against this AKS cluster. Okay, so that will be ready for use. Now, installing the GPU provisioner, we have to set up a configuration file. So downloads a bash script, and that helps generate the GPU provisioner values YAML file. So it sets up the Azure client settings, AKS cluster name, and also the workload identity information that you see right here. Now that GPU provisioner values YAML file referenced right here, okay, and so that will be the kind of the input into the GPU provisioner Helm chart. So let's run that. That has been deployed, and so what we need to do next is create a federated credential, right, against this managed identity. So first, we need to know the OIDC issuer, AKS cluster. So the federated credential, it links the managed identity to the Kubernetes service account, right? And this is what the GPU provisioner leverages this service account in the AKS cluster to have that role contributor to able to create a node pool, right? And which underneath the hood is a virtual machine scale set. Create the federated credential against that managed identity. And let's look in the Azure portal. And so we see that right here. The federated credential has been created. Kind of verify the GPU provisioner service account. Okay, and we can see that kind of mapping, that linking has been done between that Kubernetes service account to the managed identity. Workloads. If we go to the GPU provisioner namespace, we see here that it's not completely, this deployment is not completely deployed. It's kind of stuck, right? But that's because it needed that mapping with the federated credential and managed identity. So let's do a kubectl rollout restart on that GPU provisioner deployment. So that's restarted. Okay, now it is green, both deployment and the pod. Okay, and some optional verifications. The Helm chart for that is deployed, etc. If you ever get stuck with some issues, you can always check out the logs. The last major step into finally getting a language model. So right now we've basically at kind of one time set up the KAITO, right, to enable deploying language models. So right here, again, the Phi-4 Workspace YAML. This is really what makes KAITO really valuable, is that it will, based on these instructions saying that, okay, I want a node pool that will host the Phi-4 mini instruct language model, and it will do that. So that's the Workspace controller working with the GPU provisioner to deploy that. Okay, so now we're ready to deploy the KAITO workspace with the Phi-4 mini model, applying the Phi-4 workspace YAML file. So let's run that. Okay, it's being created. Now this will take about 10 minutes or more, because it's in the process of creating that node pool. So We can monitor here by watching the workspace here. We need to have basically resource ready, inference ready, workspace succeeded to be all true. So if we go to node pools, so you can see here, this is the GPU node pool that's in the process of being created. Now, the workspace has finally been provisioned. As you can see here, it took 11 minutes and all these are flagged as true. And in the node pool, we can see it's running, and we can see the VM SKU right here. And if we're to check out the NC v3 size series, we can look here, kind of host specifications. So that it ranges from 6 virtual CPUs, and the NVIDIA has 1 to 4 units, and they're the NVIDIA Tesla V100 GPUs. So in terms of pricing, this is the one that was deployed. We have here 1 GPU, and so pricing is $3.36 per hour, right? So over in US dollars, right? So over a month, you're looking at pay-as-you-go is $2,457. That's pretty pricey. Okay, now in terms of the language model, the workspace, we have the running pod and a Kubernetes service to pod. And so to test it, do some local testing, do port forward session, put up a new terminal session here. So let's test the Phi-4 mini model with the curl command. We have an endpoint here, v1 chat completions, the name of the model, the messages, the system prompt, and the user prompt. So hello, briefly introduce yourself. What is the population of Canada? And then I'm going to query for the actual message content from the JSON response. It says here, hello, I am a Phi AI developed by Microsoft, and it states that approximately 30 million people. There you have it for that. One last update to this demo I'd like to do is add an Ingress controller, because I do not like to deal with these port forward multiple terminal sessions when deploying. So in my repo, I have added some steps to deploy a Ingress controller into the AKS cluster. So there's external access network connectivity into the cluster. So here, let's just quickly set that up. We see here services here. There's no service for a public IP address. Me to that one. There's a Helm chart for the Ingress controller. So this installs the actual Ingress controller. Okay. So here, next we need to create a ingress, which is a set of routing rules. And we will see here a new namespace with the Ingress controller. Okay, and now that's been provisioned. That's great. Some Ingress services. Okay, now going back to the script here, we'll go to the Ingress Nginx KAITO, the YAML file. So the main things to look at here are the Ingress rules. Okay, so I have multiple of them to set up for future demos. So I have one for chat UI, which in a future video I'll demonstrate the installation. One for a future for RAG engine. But the one we're interested for this demo is the an endpoint for going to the Phi-4 Inference API here, right? So we're pointing to the Workspace Phi-4 Kubernetes service as we see right here. Okay, so let's apply that YAML file. Okay, it's created. Let's see here. Okay, there we go. So we have that ingress deployed, and we can see the ingress rules that helps route externally to the internal Kubernetes services. The one we're interested in is with this one right here. There we got our public IP provisioned. So let's set that up into that variable. Verification checks the health status of that health endpoint there. And now we can test against this public IP and the path Phi-4 as defined in that ingress YAML file, and then into the Inference API kind of URL endpoint right here. So again, it's the same JSON payload definition for Phi-4 mini instruct, and here's my prompt. So let's run that here. Again, I can run this curl command anywhere on the internet, and I do not rely on like port forwarding for that. So there we go. We got a good prompt right here. In summary, I've deployed this Phi-4 model with Ingress Controller. I've also outlined these steps on my blog. Okay, you can go to my blog at roykim.ca. In recap, I've shown that I've created the AKS cluster, installed the KAITO workspace controller, enabled the workload identity with managed identity, assigned the contributor role right between that managed identity and against the AKS cluster, installed the GPU provisioner controller Helm chart, created the federated credential for that managed identity, which enables the GPU provisioner to create a new node pool, and then install the Phi-4 mini language model, which becomes a inference service. I installed the Nginx Ingress Controller to have public access so that it's more convenient for demo purposes instead of creating port forwarding sessions in various terminals. And also that Ingress controller is paving the way for future demos with the RAG engine, chatbot UI, and others. And then I'll conclude with showing that test inference service with the curl command. So hopefully this helps just to give you a good overview. Again, check their documentation right here. Thanks for watching.